it there?
Yeah, I believe so. Hello everyone, Travis Reynolds. Some of you know me, some of you don't. My talk is going to be describing, more or less characterizing this bleaching event. The title I have right now is actually more or less a working title. I'd like to emphasize the fact that one of the main epiphanies out of this research is, well, it's simply the coral assemblies themselves really what drove the overall patterns of prevalence around this island. Okay, that being said, the study and how we went about it. First, I want to kind of give you a rundown of how I kind of went about subdividing the geographic regions around Guam. There's actually, through various techniques, you can kind of look at the different geographic regions, and in which case I use ordination, and I'll explain why. Then I'm going to examine the actual temperature factors that were involved in the deletion event within the region rather explicitly. And then I'm going to use 3 different data sets to kind of explore the coral and the benthic cover around the island. I do have a reference to the lower slopes. I actually kind of dropped that at the last second, but I'll talk about that briefly without any actual empirical data. And then I'm going to explore all this information in multivariate space, and this is just going to be able to give me a way to interpret the data that I collected during this event. And then finally, I'm going to identify one of the bigger significant regions, I guess, within the island itself, within this entire region itself even. And then we'll talk a little bit about what happened during the deletion event. So let me quickly kind of get through this here. Geographic regions, you can actually really, realistically, you can look at this in terms of wave exposure. We have unidirectional trade winds that occur throughout the year. Everything's pushing east. This increases the fetch and the strength and direction of the wind itself. It's going to give you kind of a metric of wave exposure. As you can see, just based on this really rough map here, far more intense on the leeward side of the island, or the windward side of the island, as opposed to leeward, east versus west. And then if you look at the island geography, you can kind of see the evolution of the island itself, where we've got the volcanic upland, and then we've got the limestone upland as well. So you can even look at it there's north and south. So essentially, you can just take this island and look at the ordination of it. You can put regions northwest, southwest, etc. And you can also just look at it as far as geographic and exposure. Okay, so this is the deletion event. This is what happens during the deletion event. We won't really get too much into details. It's a matter of the host, coral itself, and their endosymbiotic algae. They're algae that live inside them. When temperatures become too hot, typically in the summers, this relationship breaks down, and at some point the symbiosis deteriorates, and it leaves the skeletons rather pale. These are photos from the event itself. We've got Saipan, a lagoon up there. We've got an Aberchinois colony from Guam, and Millipora, platyphilia. Anyway, so that's what happens during the deletion event. It's also a massive disturbance, and that is ecologically important in ecology. So it's a great place and time for scientists, I guess, to study something like this. Not so good for the reefs themselves. During the month itself, these are the temperature products that you can look at. The top are actually the satellite derived. They're blended between nighttime and daytime temperatures. As you can see, starting in May on the far left, you've got, and by the way, the scale is actually 28 to 32, so 28 degrees C is white versus black being about 32 degrees. So as you can see, starting to come in August, it becomes increasingly hot for several months. Then right below it, these are products from Coral Reef Watch. This is a Mark Aiken product, I believe. This just kind of goes through the motions of the 2013 event itself, where you can see the maximum climatic mean, which is just like a temperature mean of like, say, 10 years, or 7, I think in this case. And then you can see this large spike on the right. This is called the reheating weeks. It just tells you that for roughly 12 weeks, you see these spikes in temperatures. And then the one on the far right, it's a little less clear because it's super tiny, but this particular incident is 3 times order of magnitude over anything that's happened in the past 15 years. So yes, it's an extremely significant event. Okay, so quickly, my methods. I'm going to be starting the whole synthesis and genesis of this project started with about 2011. NOAA did some rapid credit surveys where they surveyed fish, abundances, diversity. They did benthic work as well, but it provided a groundwork. They did this over 100+ sites between shallow, deep, and mid-range depth levels. So what we wanted to do, since this is definitely an opportunistic kind of approach, is we wanted to be able to get this information they use and provide it with a little bit of a bleaching prevalence aspect. So what we wanted to do is focus in on the shallow reef front. This is about 3 to 5 meters is our typical depth range there. And what I wanted to explain about the slope itself was that you're looking at about 6% coral cover from chronic crown thorns and various ailments that have affected the reefs over the past 50, 60 years. And this shallow reef front zone in particular is a little bit more resilient to these kind of effects. So we actually still have about 25% coral cover just in this particular zone around the island. So we went ahead and we just researched these shallow sites, and it turned out to be about 46 sites total, all over the entire island. So our methods, 3 transects, each 25 meters. We just did photo quadrants across them. We collected some macro-invert surveys. We did some qualitative assessments. But out of this, we garnered 2 data sets. The first one being the benthic cover, where we're just looking at randomized points in the benthic substrate. So we're looking at, say, sand, macroalgae, cyano, and we're also looking at coral cover itself. But the other data set that took the longest and is one of more interest, in my opinion, is the total abundance of the coral cover itself. We're actually measured the elliptical area of all the coral. And then, it doesn't say it, but I also gave indications of severity based on categories we'll look at in a minute. Okay, so this is just the summary of the benthic data set, real quick. What we're looking at is the differences between the east and the west, and I'll show you very shortly after this why we're going to focus in on this region. Anyways, the coral cover itself wasn't too significantly different between the regions. Neither was crustose coralline algae, and neither was macroalgae, cyano, I think. Yeah, cyano wasn't really much of a factor, which makes sense because this is kind of a flushed environment, so there's not going to be nearly as much cyano in this area anyways. What was significant was the coral genera and the Shannon diversity itself was just indices of the coral assemblages. So there is a difference in the assemblages themselves. Okay, so what this is just a little multivariate simple analysis called a cluster analysis. All I'm doing is looking at multivariate space and seeing the relationship between all these sites that I collected data and what does it mean. So APRO is able to make these distinctions based on ordination and using exposure and geographic region to say, okay, well, I know there's going to be a leeward side of the island and a windward side of the island. How does this factor up? Well, let's look at the cluster analysis and see what it says. It says it's a very clear distinction, and this is what this means. You got 2 groups that cluster out on the right. That almost entirely means southwestern Guam and northwestern Guam. The big cluster on the left is all obviously exposed windward sites. There's one leeward site that I can tell you right now that's, I think, Virginian on just north of Double Reef. So it would make sense since it's actually still a rather exposed area. So I ran an InnoSim on this. This is just a rank statistic that just compares the groups between these 2. And what it's going to tell you is the strength of the grouping itself. It tells you right here that, yeah, there's a little bit of a partition in these groups, but it's not nearly as clear as it could be. So +1 would be sites are completely grouped distinctly, and then 0 would be, or -1 even would be very less so in that case. So anyway, it's a significant statistic in that matter. Okay, so we're going to look at a Shepherd diagram, 1D, and the MDS displaying dissimilarities across the sites. Here we have a basic ordination of the several of the genus that